Welcome back to another video on completing the square. Now in this series of videos we've been looking at factorising quadratic expressions using this technique that we learnt about in the previous video called completing the square. And this technique that we learnt can be used to factorise any quadratic expression. So in this video we're just going to get some more practice with completing the square, and each question we look at we're just going to get progressively harder as we go down. So first of all, let's have a think about factorising this expression, and as always, pause the video and have a go at doing it yourself. Okay, so I'm assuming you've paused the video now, so let's go through this together. So if we rewrite this, this is x squared plus 20x, and then let's leave a space and then write plus 15. Now in order to complete the square, hopefully you remember that we need to half the coefficient in front of x and then square it. So half of 20 is 10. 10 squared is 100, so I need to add on 100, and now I have a perfect square. But I can't just add on 100 willy-nilly. I also need to subtract 100 so that I haven't changed from the original expression. But now I've got a perfect square, I can factorise. So this here is x plus 10 squared. 10 times 10 is 100, 10 plus 10 is 20, and then we've got plus 15 minus 100, which is minus 85. And I have completed my square. I have factorised my original expression. Okay, let's do another one. So like I said, they'll get progressively harder. So let's say we've got x squared plus x minus 7. Now, before you have a go at doing this yourself, there is a caveat. There are no calculators allowed for factorising this. So calculators are forbidden. You might see why this is slightly trickier than before. So before we had an even number here, so when we halved it, we still got a whole number. But here we don't have an even number. So it's slightly trickier, but pause the video and have a go at doing this one yourself. Okay, let's go through this together. So first of all, if we just rewrite it, x squared plus x, and then let's leave a space and write minus 7. Now, in front of the x here, the coefficient in front of x is just 1. We just don't write it. So half of 1 is a half, and then when we square it, we get 1/4. So 1/2 squared is 1/4. So in order to complete the square here, we need to add on 1/4. So if we add on 1/4, obviously I need to subtract 1/4 as well, because I don't want to change the value. And now we've got a perfect square we can factorise. So this here just becomes x plus a half squared. Half times a half is a quarter. Half plus a half is 1. And if you're wondering how I got that so quickly, it's just this number here. Okay, this number just goes in here. So it's quite easy to substitute. And then I've got minus 7 minus a quarter, which is just minus 7 1/4. And I have completed my square. You can, if you wanted to rewrite this as an improper fraction, you can. 7 1/4 is the same as 29 over 4, so I could write this as 29 over 4, and that is my answer. Okay, let's do a couple more. So if we scroll down, let's do a couple more here. So let's say we've got, what can we say? Let's say we've got x squared minus 3x minus 5. So as always, pause the video, have a go at factorising this yourself. Okay, let's go through this together. So first of all, just rewrite it, x squared minus 3x, and then we'll leave a space, and then minus 5. So we need to half the coefficient in front of x. So half of negative 3 is just negative 3 over 2. And then when we square it, negative 3 squared is 9, 2 squared is 4. So in order to complete the square, I need to add on 9 over 4. So if I add on 9 over 4, okay, I can't just stop there. Obviously, I need to subtract 9 over 4 as well. Okay, now we've got our perfect square, we can factorise. So this here is just x minus 3 over 2 squared. And again, if you're wondering how I got that so quickly, it's just this number here. So x minus 3 over 2 squared. And again, if you wanted to check that, you can expand the bracket. So negative 3 over 2 times negative 3 over 2 is positive 9 over 4. And negative 3 over 2 plus negative 3 over 2 is negative 3. and then we've just got minus 5 minus 9 over 4. So minus 5, that's the same, if I get a common denominator of 4, that's the same as minus 20 over 4. If we subtract another 9 over 4, so minus 20 over 4 minus 9 over 4, that is minus 29 over 4. So I can just rewrite that as minus 29 over 4. And we have completed the square. We have factorised our original expression. Okay, this is fun. Let's do one more. Let's do one more to finish it off. So let's say we've got the expression x squared plus 7x minus 6. Okay, so first of all, if we rewrite this, so x squared plus 7x and leave our space so we can complete the square, and then minus 6. So half the coefficient in front of x and then square it. It's the same every time. So half of 7 is 7 over 2. And then when we square 7 over 2, 7 times 7 is 49, and 2 times 2 is 4. So 7 over 2 squared is 49 over 4. Okay, and I'm just going to stop you there because you might have been tempted to do 3.5 squared, and technically that's not wrong, but it's a lot harder to do 3.5 squared than it is to do 7 over 2 squared. If we were doing 3.5 squared, we'd have to do 3.5 times 3.5, and then 5 times 5 is 25, so carry the 2, 5 times 3 is 15, plus the 2 is 17, so that gives us 175, and then put the 0 in, and you can probably see where this is going. It's a lot more complicated to square decimals than it is to square fractions. Okay, so whenever you're completing the square and you're taking half the coefficient in front of x and then squaring it, always leave it as a fraction. That's my tip to you, is always leave it as a fraction, because it makes it a lot simpler. Okay, because we just square the top number, square the numerator, and square the denominator. Okay, so in order to complete the square, we need to add on 49 over 4. So plus 49 over 4. Obviously, we need to subtract 49 over 4 as well. Okay, so now we've got a perfect square. We can factorise. So this here just becomes x plus 7 over 2 squared. So it's just this number here. And then we've got minus 6 minus 49 over 4. So to work that out, let's just get a common denominator of 4. So minus 6 is the same as minus 24 over 4. And then minus 49 over 4. So minus 24 over 4 minus another 49 over 4. That becomes minus 73 over 4. So I can just write that as minus 73 over 4. And that is our final answer. So we have completed the square. So hopefully you can see that it doesn't matter what quadratic expression we've got up here. We can factorise any quadratic expression by completing the square. We just need to half the coefficient in front of x and then square it. And when we add that on, we have a perfect square. But also, you just need to remember that if we're adding on something, we need to subtract it as well, because we don't want to change the original value of our expression. Okay, so hopefully you got a lot out of that video. And I'm just going to do one more video where we're going to apply this principle of completing the square to go on and solve some quadratic equations. So I hope you enjoyed that, and I'll see you in the next video.